just did this, but we have to know how to simplify radicals. Because there's a whole bunch of the problems that actually we have to do other things, but then we get to the same point where you got to like simplify the radical in front of you. The cubed root of 40x to the 7th y. I mean, you got to look at the 40 and say, is it a perfect cube? And you know, you have a formula sheet in your hand, so you need to at least be able to look at it. In fact, 40 is not a perfect cube. Does it have any factors that are perfect cubes? 8 is a perfect cube. 8 times 5 is 40. So you would split it up. 8 times 5. Okay. Would we be able to take out all of the x's if it's x to the 7th? Right? Because the 7 divided by 3 doesn't go evenly. What's the next highest number? Less than 7 that's divisible by 3. 6. So let's make it x to the 6th times x. And how about that y? Are we going to be able to do anything with the y? No, because it would have to be there at least 3 times, so you could take it out once. It's only there once, so that part won't be simplified. Right. So now we take the cubed root, the cubed root, the cubed root, the cubed root, the cubed root. And you simplify what you can. In this case, that's 2 times the 3rd root of 5. How many x's come out of a 3rd root of x to the 6th? 2, right? 6 divided by 3 is squared. Okay, the 3rd root of x can't be simplified, and the 3rd root of y can't be simplified. So then we put together all the things that are outside the radical, 2x squared, and all the things that are inside the radical, cubed root of 5xy. Right? It's very systematic. You just got to look at it, especially if you got all the simplified roots like in your hand. There's not much excuse for not being able to just kind of systematically go through this process. And you know, if you see all the work that I'm doing here, you probably should have about the same amount of work. I'm not doing this work for you. I'm doing it for me, because that's how you do a problem like that.